Have you ever walked outside on a clear night, gazed up at the stars, and thought, wow, I wonder how many stars are out there? Well, why stop there? Let's kick it up a notch. How about the number of galaxies in the universe? No? Still too easy? Alright, let's get nerdy. How about how many particles are there in the universe? Now, that's a question to answer. And who better to help us with this cosmic calculation than the sci fi genius and master of estimation himself, Isaac Asimov, who took a crack at it in his book, Please Explain. Now, we can never truly know the exact answer, for no one really knows how big the universe is. But that's the beauty of physics. We can guesstimate. Guesstimation is a really powerful tool when it comes to physics. Large numbers can be crazy hard to wrap our heads around, but with the magic of mathematics, we can actually throw some numbers around and sound almost believable. So let's dive into Asimov's cosmic counting game. How do we start off? Or where do we start off? How do I deal with this problem? So let's start off with a few assumptions. Without assumptions, we can go nowhere. My first reasonable estimate, or our first assumption here, is there are 10 power 11 galaxies in the universe. Now, why did Asimov choose 10 power 11? Did he just throw some random number out there? No, this is a pretty well rounded guess. So, if we just slide through here, what I can see here is an image by Hubble. So, back in 2004, the Hubble Space Telescope took a million second exposure of a tiny patch of sky. I mean, tiny, only about 3 arc minutes across. From the image, scientists could actually count the galaxies and scale it up to the entire sky. So, what we can do here, looking at this image, is basically, let's say, I divide this image into 16 pieces or 16 parts. Each box or each tiny box that I see here, each tiny part that I see here, if I could estimate just by looking at it, I can say there are around 150 galaxies here, maybe 150 to 151 galaxies. Now, if I integrate this over the entire sky, I get roughly 39 billion. Yes, you heard me right. 39 billion galaxies. Scientists looked at this carefully in a little more detail, and they scrutinized this picture and analyzed it a lot more, and they found out each of these tiny boxes actually contains nearly 625 galaxies. And if I integrate it over the entire sky, I arrive at a whopping huge, massive number of 165 billion. You're right. So there are approximately 165 billion galaxies in the sky. So what we have here, what we had estimated here, which was around 100 billion galaxies, is not far off. It's a well rounded number. So I think it's quite an educated guess. So that's one reasonable assumption out there. And now, okay, I have a reasonable estimate to reasonable answer as to how many galaxies are out there in the universe. How do I proceed? Right. So, what one can do is look at how much matter is present, right? Each galaxy is 10 power 11 times as massive as our sun. Each galaxy is nearly 10 power 11 suns. It's almost 10 power 11 times as massive as our sun. So we have this out there. Now, okay, that implies that my universe, right? My entire universe is 10 power 11 galaxies into 10 power 11 suns, which is basically the total matter content that I'm looking for. 10 power 22 suns worth of matter is what I have in my entire galaxy. Guys, this is 1 followed by 22 zeros. That's 10 sextillion. That's a huge number, pretty mind blowing, right? Now, let's focus on our good old sun. What about its mass? How massive is my sun? How much does my sun weigh? So, the mass of the sun is around 2 into 10 power 33 grams. How did I pull out this number? One can actually equate the gravitational force and the centripetal force, which, if you have time in your hands, you should do this, you should check it out. It is an excellent way to kill a few minutes. By balancing out the gravitational force and the centripetal force, you will arrive at the mass of the sun, which is around 2 into 10 power 33 grams or 2 into 10 power 30 kilograms. So, oh, all right, now I know the mass of my sun. I know how many galaxies are there. I know the matter content. Let's proceed. If, let's say, I multiply my 10 power 22 into the total mass of the sun, what do I get here? I essentially get the entire mass of the universe, because I know that my universe matter content is equal to 10 power 22 suns, and my sun weighs around 2 into 10 power 33 grams. If I multiply those two, I will get a whopping 2 into 10 power 55 grams. Wow, I have with me here the mass of the universe essentially. Alright, now my ultimate goal, or what my ultimate aim is, basically to calculate the number of particles in the universe. So it's always nice to backtrack and see what our aim is. And our aim here is to calculate the number of particles. Right. So now, when it comes to counting individual particles, we've got to call our old pal Avogadro. He says 1 gram of matter contains 6.023 into 10 power 23 nucleons. Alright, I know that my universe weighs 2 into 10 power 55 grams. Can I calculate the number of nucleons in my universe now? Yes, indeed. And that would be equal to 2 into 6.023 into 10 power 23 into my 10 power 55, right? Which is equal to another massive number here, 1.2 into 10 power 79. Wow. Does this number even have a name? Actually, it does. We'll get to the good part. We'll get to the fun stuff later. Alright, so far I think it's pretty simple, pretty straightforward. Now, let's drift from the main topic at hand. When I look at the universe, let's say I grab 100 atoms out of the thin air. Out of thin air, I grab 100 atoms. Let's break let's break down as to how those atoms actually look like. Astronomers believe that if we take these 100 atoms at random, about 90 of them would be my hydrogen atom. I would have 9 helium atoms and one heavy element, let's say one oxygen atom. There are other elements, but oxygen is the most abundant one here. So I will be considering oxygen. Now, how many nucleons does my hydrogen atom have? So I know that my atomic number for hydrogen is basically 1. That essentially tells me that there is 1 nucleon, which happens to be a proton, let's say. Now, I have 9 helium atoms here, alright? And helium atom is essentially nothing but 4 nucleons, correct? Which is nothing but 2 protons plus 2 neutrons. So my helium atom contains 4 nucleons, which is nothing but 2 protons plus 2 neutrons. How about my oxygen atom? My oxygen atom has 16 nucleons, right? Which is basically 8 protons plus 8 neutrons. Alright. Now, if I sum up all my nucleons for 100 atoms, for all these 100 atoms, if I sum up my nucleons, I get 142. So essentially I have 142 nucleons in total. And if I write down the number of protons and neutrons, that would be 116 protons plus 26 neutrons. Alright. One must remember that our universe is electrically neutral. So for every proton here, it needs to have an electron buddy. So if there are 116 protons, it logically implies that I have 116 electrons, right? For every proton, there is a corresponding electron to maintain electrical neutrality in my universe. So I have 142 nucleons here, right? In total, I have 142 nucleons. Out of 142 nucleons, I know there must be 116 electrons. Again, this is stemming from the fact that there are 116 protons, and we need to maintain the electrical neutrality of the universe. Therefore, we have 116 electrons here. And for every 142 nucleons, I have 116 electrons. The number of nucleons, we had already estimated this. This was around 1.2 into 10 past 79, right? So, how many electrons should be there in my universe? This is a simple problem. It is basically 1.2 into 10 power 79 into 116, right, divided by 142, which will essentially give me 1 into 10 power 79, 1 into 10 power 79 number of electrons that I have here. Wow, that's an insanely large number again. So we are on to our final step. I have my number of nucleons, which is supposed to be 1.2 into 10 power 79, and the number of electrons I have here is 1 into 10 power 79. So my final tally is 2.2 into 10 power 79 particles in the universe. Wow, let's just take a step back and try to admire this insanely large number. By the way, do you want to know how to pronounce this number? It has a very funny name. It's called 22 quintillion. This is basically nothing but 22 quintillion. So the number of particles in the universe is 22 quintillion. I mean, that's an insanely large number indeed. Now, what if the universe was half matter and half antimatter? That would imply half the particles are anti-electrons and anti-nucleons, but that would not really affect our total number that we have right here, right? Half of it is going to be your anti-electrons and the other half is going to be your anti-nucleons, so our number remains the same. We have to, acknowledge that we skipped over a few things like isotopes of these elements, and we skipped the photon, the number of photons here, neutrinos, and maybe even gravitons if they exist. But hey, those are all massless particles, right? And we are sticking to the big, chunky stuff for now. And there you have it. We just guesstimated the number of particles in the universe, 2.2 into 10 power 79 particles. And Asimov here says that's a pretty sizable number and has the potential to actually span the entire universe that we see. Can you think of a number that is bigger or greater than this? Hmm. Well, the number of chess games that could be played? I've heard that it's in the order of 10 power hundreds. So that's huge. That's in fact the number of chess games that can be played is in fact larger than the number of particles in the universe, which is quite astonishing. And there you have it. If you enjoyed this wild ride through the numbers and the cosmos, don't forget to subscribe to Quarks for coffee breaks for more bite-sized brainy content with a sprinkle of humor. Drop a comment with your favorite mind-blowing space fact, and I'll catch you in my next video.